All right, let's begin with our first example from Chapter 4. And so example 4.1, we're asked to write a loop that computes the first n elements of the geometric series. A of I plus 1 is equal to A of I divided by 2, with A of 1 equals 1. So the first element of the sequence is 1, and then all of our subsequent elements are equal to the previous element divided by 2. Excellent. Okay. This is also a good example because before we've learned about vectors, we considered the geometric series back in example 3.4 in the previous chapter. And so hopefully you'll find with vector notation that solving or calculating the geometric series becomes a much simpler task. Okay, so now here I am over in MATLAB, and I've tried to keep the problem statement from the text open at the bottom of the page. So if you need to recall what the geometric series is, it's there. Okay, so we're asked to create a script to calculate the n elements of the geometric series, where n would be specified by the user. Okay, so I'm going to start by creating a new script. So in terms of description, this script will calculate the n elements of the geometric sequence. So the series would be the sum of the sequence, I suppose. So in terms of preconditions, we'll need n, the number of elements. And then in terms of postconditions, a vector containing the geometric sequence. Okay. All right, so to get things started, we're told that the first element of our sequence is 1. Okay, so maybe I would say initialize the first element. Okay. So the first element of our sequence, A of 1, is equal to 1. Okay. So in MATLAB, right, A is going to be a vector. We're going to have a vector that's going to store the elements of our sequence. And we want to store a value to the first element. Okay. So it'll be A, which will be the vector that contains, in the end, all of the elements of our sequence. In parentheses 1, the first element, we want to assign a value of 1. Bam. And that's it. Okay. So let me save save this. I'm going to call it geometric series.m. Okay. If I want to test it as I go along, geometric series. Right. If I run it, I get A is equal to 1, because at this point, A is just going to be a single element that I've assigned 1 to. Okay. So let me clear A and get back to business. Okay, so I'm going to go back and resilence the output. So if I look at the problem statement, I did the first part. I assigned to the first element of my sequence a value of 1. And now we want to set up a for loop to compute all of the subsequent elements of the sequence. Okay, so I'm going to set things up with the for loop, okay, where I'll use I as my index variable. So now the question is, what do I want to loop from, and what do I want to loop to? So if I stick to the notation in the problem statement, we have that A of I plus 1 is equal to A of I divided by 2. Okay. So if I think about calculating, the first calculation will be to compute the second element, then what I'll want is I to be a value of 1, so that to compute the second element, I have A of 1 plus 1, A2. Okay. So I'll start my loop as going from value of I is equal to 1. And then what do I want to end with? If I want to calculate the first n elements of the sequence, or the n elements of the sequence, so if I look at the problem statement again, so if I want to go up to the nth element, then in the last iteration I want I to have a value of n minus 1. Okay. Why? Because then in this last iteration it'll be n minus 1 plus 1, which will just be n. Okay. Excellent. Okay. So now this is fine. Okay, but sometimes I get confused or unsure about order of operations when I have things like colon operators in here. So to be safe, I could take the n-1 and put in parentheses. So I make sure that MATLAB evaluates this as n-1, and then it can perform its colon operation. Okay, excellent. Then what do I want to do each loop iteration? Well, we set it up now so that we can just follow the equation from the problem statement. So if I want to compute the I plus 1 element, I can. So first loop iteration, I will be assigned a value of 1. And so this will correspond to calculating the 1 plus 1 second element of my sequence. So my second element is equal to my first element, A of I, divided by 2. Okay. And that's it. Okay. Each time I will be incremented by a value of 1 all the way up to n-1. And yeah, that's it. And so hopefully you can appreciate the simplicity of this compared to how you would have done it before. Not only that, now if I just type n or a at the end to display the value of a, working with the vector, just typing a now, I'm going to be able to spit out all of the elements of the sequence. And if I just wanted a specific element, I could just specify an index and point specifically to that element. So to test it out, if we want to compute, say, the first 10 elements of the geometric sequence, I can assign 10 to n, and then let me run geometric series. Okay. A is a vector of length 10, right? And then MATLAB is going to display to me all of the elements of that vector. Excellent. That's all there is to it. Okay. So thinking ahead, I'm going to make a couple comments about assigning values to vectors that we'll come back to later on in this chapter, or touch on a little bit later on in this chapter and later on in the semester. But being the first problem, it's the perfect opportunity to introduce what MATLAB's not complaining about, but the suggestions they're giving in the editor here. Well, first you'll notice, as always, this A at the end is highlighted, and so all it's suggesting is that we suppress the output. Right? Typically, you want to suppress the output depending on the calculation. Okay, so we can ignore that because that's the effect we want to display A. But if I look up here, okay, A is underlined. And the notation, or what we're told, is the variable A appears to change size on every loop iteration within a script. Consider pre-allocating for speed. Okay. So the issue here is that when we first initialize A, at that moment right there, A is a scalar. It's a vector of length 1. So MATLAB's going to assign a specific amount of memory to store that single element. Then what happens is each loop iteration, we grow A by a value of 1. Okay? And so what I mean is just working interactively. If I have a vector B, and I say B of 1 is equal to 2, and then next iteration I say B of 2 is equal to 3, right? B is going to grow from a vector of length 1 to vector of length 2, right? A scalar to vector of length 2. And so when I grow the vector, MATLAB needs to reallocate the memory assigned to that variable. And it could be, well, it's not, you won't notice it as a time-consuming operation, but from a computer science type of perspective, it's not the most efficient thing that could be done. Okay, and so what MATLAB's complaining about here is that we're defining our vector dynamically. It's growing each iteration, so each iteration it needs to reallocate memory to store that variable, and it's saying it's not the most efficient. And so what they would ideally want you to do is, since we know that A will ultimately be a vector of length n, would be to initialize or pre-allocate, or when you define the variable for the first time, define it as being that final size so that it assigns all the memory it needs at the very beginning that it'll need to store all the results in the very end. And so what they would like you to do is something of the order of, so if I want to pre-allocate or pre-size vector A, would be something like A is equal to zeros, 1 comma n. Okay, and so we'll learn more about zeros later, but zeros is like 1. Zeros is like ones. It'll create a vector or a matrix of all zeros. And so the notation is zeros will have 1 row and columns. Okay, so 1 row and columns. It'll create what's called a row vector, single row and columns. Vector, as we've been seeing it, of all zeros and of size n. And you'll notice once I did that, this is no longer underlined. So what happens now is, right, if I were to do, say, b of b is equal to zeros, 1 comma 10, right, it's going to create a vector of length 10 of all zeros. So then here I write to the first element, and then every loop iteration I write to the ith element. But since I'm not specifying an element outside the bounds, my vector is not changing size, so MATLAB's happy from that perspective. Okay, and so if I were to, and let me clear A, if I were to run geometric series again, right, I get the same result just as before. You're not going to notice a difference in computational speed, but in theory, it's more efficient under the hood.